aka Destiny Multinational Company. So we are talking about what? Chemistry, factors affecting what? Rate of chemical what? Reaction. One of the factors that we're talking about, what are the factors affecting rate of chemical reaction? Before then, we were talking about the Chatterton's principle. What is the Chatterton's principle? Okay, the Chatterton's principle we're talking about. The Chatterton's principle states that was when the system is in equilibrium and any of the factors responsible for equilibrium is altered, the system was shift just to alter or another effect of its what? Change. So those are the things about the Chatterton's principle. So what are the factors affecting chemical equilibrium? We have what? The temperature. We have the pressure. Pressure for what? Gaseous what? Reactants. That means the reactants should be what? Gas. And so have what? Concentration. Those are the three factors that affect what? Chemical equilibrium. Remember in our last class we talked about factors affecting chemical reaction. We give about 7 factors: temperature, pressure, concentration, light, catalyst, surface area, and so on and so forth. So, but in this one, we have, out of all the 7 factors, we have only 3 factors affecting what? Chemical what? Equilibrium. Now, under temperature, you can see that this is a chemical equilibrium. Talking about was a reversible process. When N2O4 goes further, it's going back to what? Gives you NO2 and also gives back to what? N2O4. So the reaction is what? In a closed system. So for a chemical equilibrium, it ought to be what? In a closed what? System. Let's see now what are the characteristics of equilibrium. 1, it's a dynamic process. That means a continuous process. That means that dynamic process. 2, the concentration of the reactant and the product remains constant. So the reactant and the product will always remain constant. No one is better than any other. It takes place in a closed system. For a chemical equilibrium to take place, it must be in a closed system. That is delta H should be equal to what we mean at equal. Delta H should be equal to what? T delta S. Delta H should also be equal to what? T delta S. Remember when we talk about enthalpy, we talk about delta H equals to H of product minus another enthalpy. We say delta H equals to what? Delta H should also be equal to what? H of what? Product minus H of what? Reactant. And also that's for enthalpy. We also talk about entropy, is the heat content of the chemical reaction or heat of the what? System. I also talk about what? Entropy, which is what? Delta S can be what? Delta H over T over what? Delta T. We're talking about what? Entropy of the world system. And when you cross multiply, therefore we are having delta H plus what? T delta S, which is what we are having here. So it must be in the world closed world system. And if you just move this one to this side, definitely here should be 0. So if you move this one to this side, you have 0 is equal to what? Delta H minus T delta S. That shows that what? Here should be equal to here. It shows that what is in equilibrium. And when delta G is 0, it also tells us that it's in equilibrium. But when delta G is negative, it's what? Spontaneous. And also when delta G is what? Positive, it's not spontaneous. So for a reaction, it also be what? Spontaneous, so that the reaction can what? Proceed. We talk about what are the factors. They say the system resists change in what? In factors governing the what? Equilibrium. So all these are the factors responsible for what? These are the characteristics of equilibrium. For something to be in equilibrium, it must possess this what? Characteristics. Let's move to the next one. We talk about temperature. So we talk about there are 3 factors from temperature, pressure, and concentration. Under temperature, either it's an endothermic reaction or an exothermic reaction. What do you mean by endothermic reaction? For the meaning of endo means gives out. That is gives the heat content of a chemical world system. For the endothermic reaction, it gives out heat to be what? Surrounding. And the reaction vessel is going to be what? Hot. And for exothermic reaction, it absorbs heat from the surrounding. The reaction vessel is going to be very what? Cold. So for an endothermic reaction, delta H is going to be positive. So if delta H is going to be positive, how do you know an endothermic reaction? You say we are going to say what? Delta H is equal to what? Product minus what? Reactants or reactant. What are the products? So sometimes you calculate the number of moles of the product, which is the product here should be what? This is the product. So we say product is what? In this case, this is a product we are trying to reaction. How do you know endothermic reaction? Sometimes we be careful about doing that. We say product over reaction. So the product is what? Product over what? Reactant. Product is what? 2. Which is what? 2 over 1 plus 1. 2. 2 divided by 2 is what? 1. As I said, delta H should be what? The K constant should be what? Greater or equal to 1. So it can be 1, it can be 1.5, it can be 2, and so on and so forth. So in that case, endothermic reaction can what? Take place. Alright, so this one is an endothermic reaction and it proceeds in forward direction. But how do you know an exothermic reaction? We said that it's going to be lesser than 1, which is product is 2, which is having delta H is what? Product minus what? Reaction. And product is what? 2 over reactant 3 when it's gas. So 2 over 3 is 0.066667. So see that what is lesser than what? 1. Therefore, we can call it what? An exothermic what? Reaction. So with all this, you can be able to check all these ones. Once they are gas. The other ways you can see dictate. Sometimes be careful when you have what solid, because solid what appears as unit 1 in a chemical reaction, and it doesn't really count. Now let's look at this. For endothermic reaction, increase in temperature favors the what? Forward direction. So when you increase temperature, the forward direction is favored, and the equilibrium shift to the right. So it's like forward direction is favored. And a decrease in temperature favors the what? Backward direction. That is the equilibrium shift to the what? Left for an endothermic what? Reaction. For an exothermic reaction, the reverse is the case. Increase in temperature favors the what? Backward. Remember that endothermic reaction, increase in temperature favors the forward. But exothermic reaction, increase in temperature favors the what? Backward what? Reaction. So equilibrium shift to the left. While a decrease in temperature is the opposite of what is there, favors the what? Forward direction. And equilibrium shift to the what? Right. So that is to say, for endothermic reaction, when you increase temperature, forward reaction will be favored. But when you increase temperature here, backward reactant is favored. When you decrease temperature, backward reactant is favored here. But when you decrease temperature here, forward reactant will be favored. So if our attempts is established, we move to what? Concentration. Concentration. From temperature, we're talking about what? Pressure. For pressure to take part in the reactant, what do we mean? It means that it's sure that only the reactants, okay, either the reactant or product must be gas. Because chemical equilibrium, either this or this should be what? Gas. So for chemical equilibrium, there must be gas in any of this equation. If there is no gas in any of this equation, that is to say, pressure cannot take place. Now, what are the factors affecting pressure to take place in equilibrium? One, the number of moles of product should not be equal. So because if the number of moles of products are equal, pressure cannot take place. Can pressure take place in this reaction? No. Because the number of moles here is what? 2. In the reactant, the product is 2. So pressure cannot take place. The other factors can say that what? There must be what? Gas in the reactant or product. So if the reactant or product have the what? Gas, pressure can take place. Though this one favors the second condition, which is one of it. In short, there is a gas in the equation. But it didn't favor the first definition, which will say that what? The number of moles must not be equal. You can see in this case, the number of moles are equal. So because the two conditions must be established before pressure can take place. So in this case, temperature can take place here, but pressure cannot take place. That's in this case. Now let's see. But in this case, this is 3, 2. The number of moles are not equal. Is there gas? Yes, there is gas in this reactant. Even here can be steam and so on, or steam. So you can see that what? Pressure can take place in what? In this what? Reaction. But pressure cannot take place here. Temperature can take place here. Temperature can take place here. Pressure cannot take place here. Pressure can take place here. So for told you earlier on that the factors affecting chemical the product we're talking about pressure in the number of moles of the reactants must not be equal and there must be gas. So also if pressure, what is the definition of pressure? Increase in pressure favors the side that was decreased, that has a decreasing number of moles of volume. Why decrease in pressure favors the side that has what? Increase. Now because we know that pressure cannot take place here, we know that pressure can take place here. When you increase pressure, there will be favors. This side is having what? Higher number of moles. Remember that I said we say increase in pressure favors the side that has a lower number of moles of volume. So that means it has a lower pressure. If you increase pressure, there will be favor because here has a lower pressure. Why if you decrease pressure, there will be favor because here has a higher pressure. So look like inversely proportional. So increase in pressure favors the side that has a lower pressure or lower moles of volume. So when you increase pressure, here is lower because here is 2, while here is 3. There will be favor. And if you decrease pressure, there will be favor. So with that, and also look at this one, can pressure take place? Yes, because one, there must be gas, and also the number of moles and products are not equal. 4, 2. So pressure can also take place here. So if you increase pressure here, what happens? This side will be favored. This side will be favored, but this side is smaller. And if you decrease pressure, there will be favored. That's how we can go to what? Solve something of what? This nature. And can pressure take place here? No, pressure cannot take place because they are solid in reactant, so pressure cannot take place. But temperature can go and take place. Can pressure take place here? Yes, because this gas. But if you look at this, in this case, how can pressure take place? Increase the number of moles. Can pressure take place in this reaction? You can look at it very well. No. Why? This is solid, this is solid, so this and this is gone. So we are looking at 4 and 4. So pressure cannot take place in this reaction. Let's look at this case. we'll talk about what concentration. Adding concentration to any of the species, favor a side that was not added. And removing concentration from the species, favor a side that was added. Let's look at this case. Adding concentration to any of the species favors the side that was not added. So if you adding concentration to here, more of CaCO3, here will be favored. Adding concentration to any species, if you adding concentration to here, here will be favored. If you adding concentration to here, here will be favored. Of the two, we add to the reactants. If you adding concentration to the reactant, the product is favored. If you are removing concentration from the reactant, favor the side that was removed, here will be favored. So if you adding concentration to here will be favored, the product will be favored. But if you remove concentration from here will be favored. Also, if you are adding concentration to this reactant and it's an open system, of a truth, you are removing from here. You can see it now. So if you are removing from here will also be favored because the favored side that was what removed. So with all this, guess you know to understand things about what chemical or the equilibrium and what's happening on this channel for more information. Thank you very much. This is Despirando TV. Don't forget to subscribe and like. Bye for now.